All right. So in this case, we are going to consider how to apply our Pythagoras theorem. That is the theorem of the Pythagoras. It is very, very important that we do understand this theorem. In our calculations, we just need few things just to understand the theorem of Pythagoras. So let us just have this theorem of Pythagoras. That is the Pythagoras. So it is just the Pythagoras theorem, all right? The Pythagoras theorem, which is the theorem of what? Pythagoras. It is used, or we are going to apply this on a right-angled triangle. If you are given basically a right-angled triangle, what is it that you consider here on a right-angled triangle? Let me just put it aside here. That is right-angled triangle. Just gonna also write this in short. So a right-angled triangle is the one that we see with a 90-degree. This part here is a 90-degree angle, 90 degrees. That is a right angle. This angle that we are seeing, it is equivalent or it is equal to 90 degrees. And in a right-angled triangle, that will be the biggest angle that you're going to have. Consider this. Remember a triangle, these angles, they add up to 180 degrees. A normal triangle that we are used to, angles inside, they add up to 180 degrees. So meaning to say, if you are to subtract 180 minus the 90 degrees, what are you going to have? You are going to remain or to have a 90 degrees. Meaning to say, as we have removed this 90 degrees out of these two angles, these ones, we are going to remain with 90 degrees, meaning to say the two angles that are remaining, they are sharing 90 degrees. These two angles, this angle here and this other angle, they are going to be sharing this 90 degrees. So definitely there will be less than 90 degrees. Maybe this one is a 20, this one is a 70, maybe this one is a 45, this one is a 45. We are not going to have a condition where there is a 90 degrees, then we have an angle that is bigger than 90 degrees. Like, let's say this becomes 100. It cannot happen. So that's why I'm saying in a right-angled triangle, the biggest angle that we are going to have is 90 degrees. So knowing this, that it is the biggest angle, it therefore corresponds to say this side, which is opposite to that biggest angle, this side that I'm indicating here, that I'm showing there, it is referred to as the longest side, which is the hypotenuse. It is the longest side ever that we are going to have in a right angle triangle. That will be the longest one, the longest side. So this is given. Remember, this was taken from the Greek. So from those Greek name, that is where we have the hypotenuse. So it is just a special name that we are going to use there, which is referred to as the hypotenuse, but it simply represents the longest side, the hypotenuse. So the other sides will be called what? These are the shorter sides. This side is called, it is just a right-angled side. A right-angled side, which is at this 90 degrees, the other one. But these are the shorter sides because we said this is the longer side. So this one and this other side are simply called the right-angled sides, all right? Or they are simply the shorter sides that we have. If this is the longest side, therefore these two sides are what? Are the shorter sides. So from this theorem of Pythagoras, it states that whenever we are given this hypotenuse, the theorem states that the hypotenuse squared, that is the square of the hypotenuse, is equal to the square of these shorter sides, the sum of the square of these shorter sides. So we are simply referring to the right side. I'm just going to write in short. This right angled side, I'm just going to write it as what? As right side. So it's right side squared plus another right. It's a formula that you need to know. All right. So that's plus another right side squared. So this is the condition that you are going to have. Meaning to say, if I was to have this triangle, let's say our triangle was like this, and it's referred to as ABC, ABC, triangle ABC like this. So the side opposite to the angle A, this one, just going to call it A, all right? So this one, just going to call it A. This one opposite to B, just going to call it B. This one opposite to C, we're just going to call it C, small letter C. So using these letters, the formula that I have written here is simply going to give us this condition: the hypotenuse squared, the one that is opposite to the what? The one that faces the 90-degree angle, the right angle, is C. So that C squared is equal to the right side squared, right side squared. These are the remaining shorter sides that we see, the A and the B. So it is going to be A squared plus B squared. So these are the shorter sides. These ones, the right side, these are simply the shorter sides. These are the shorter sides. Okay, so these are the shorter sides, meaning to say any order can be used, or you can take any order there. You can start with B, then you end up with A. You can start with A, you end up with, it's up to you. But C is representing what? The longest side, which is our hypotenuse. So that is the condition that we are having there. So using this formula, guys, we can determine any side. Is it the hypotenuse that we want? And is it a condition whereby you're calculating the shorter sides? You can use this formula, play around with it as you are solving your equations. It can be like that, where you can determine whatever that you want. But that is the condition of your Pythagoras theorem. So let us consider working with the formula, working with our Pythagoras. Write a Pythagorean equation for each of the following triangles. For each of these triangles, you're supposed to give a Pythagorean equation, meaning we are supposed to give an equation of this nature as we stated it from A, B, C that we had from that triangle. All right. So they want you to have an equation from these triangles that you're given. Explain what each letter symbol represents, just like what we had to say C represents the hypotenuse, then A and B, these are the shorter sides or the right sides. So that is what they're asking you in this case. Okay, so what is the formula? Let's start with the first one, the first triangle. Let's call this one A. This is our first triangle. What is representing the hypotenuse? Remember, the formula does not change. Hypotenuse is squared. The side which faces what? The 90 degrees. That is our hypotenuse. I'm just going to write in short. That is our hypotenuse. So the formula is hypotenuse squared. That is y squared is equal to what? The sum of the square of the shorter sides, the one that are remaining. What is remaining from our shorter sides? We have got x and we have got a z. So we're going to square those two. So that's x squared plus a z squared like this. That is our formula. Hypotenuse squared. So where this y represents what? The hypotenuse. Like I said, I'm just going to write in short. And this x and z represents what? These are our shorter sides, or the right angled sides, the right sides. We have the hypotenuse and the shorter sides. So they want you to have it in terms of the letters that you're given. All right. On this one, let's call this one B. In this triangle, we can see that the 90 degrees, the right angle there is facing what? Q, opposite to this Q. So Q becomes the hypotenuse. As long as you have the hypotenuse, you are done. So you know that the square of this hypotenuse is equal to what? the sum of the square of these other sides that are remaining, the shorter sides. That is the P and what? The R being squared. So that's P squared plus R squared. That's just that's the condition that we have, where the Q squared represents what? That's why the Q, this Q is the hypotenuse. The P and the R, these letters, letter P and this letter R are the what? The shorter sides. Those are your shorter sides. So they just like that. So if you consider the last part that you are given, let's just call this triangle C. We are given, according to this triangle, if we check the right side, the right angle triangle is here. I mean, the right angle is here of the right angle triangle. This is where we have our right angle. Opposite what? It faces this side, which is E. So it follows that E squared is equal to the hypotenuse, the sum of what? The shorter sides, which is D squared plus what? Plus F squared. So that is how you simply take this. So this is your hypotenuse, and the D and the F represents what? These are your shorter sides, right? So they were supposed to write properly to say D is a shorter side, F is a shorter side. But here I'm just giving you in a short, like what you were going to have. So if you consider Pythagoras theorem, it's nothing, guys. Calculating the length of the hypotenuse on these questions we are given, use the formula for the theorem of Pythagoras. What are we supposed to do with that formula? To calculate the length of the hypotenuse, leave your answer in said form if necessary. If necessary, that is where we cannot determine the square root of that number. Let's say the square root of 10. We do not know the square root of 10. We can leave our answer under the square root. That is what they say. But where we can determine, let's say the square root of 100, where we know it's 10, we cannot leave our answer under a square root because we know that. So that is why they are saying if necessary. Number one, how are we going to apply our formula? Pythagoras theorem. According to our triangle, the side that we want to calculate is this side of AC. This is the side of AC. So we can use the sides to say the side AC as it is. This is the one that faces what? The 90 degrees. So the side AC, that's our hypotenuse. So AC squared is equal to what? The sum of the shorter sides. The shorter sides are these two, representing what? A to B and B to C. So you've got AB as a side and BC as a side. These are the shorter sides. So we can put in our values in what we are given. As we can see, we do not have the length of AC. It is the one that we need. So we're just going to rewrite as it is. AC squared is equal to what? AB squared. What is representing AB? We substitute, that is a 3. So that's 3 squared. All right. So you're going to substitute 3 squared plus BC squared. What is representing BC? That's a 4. So this is going to give us 4 squared. Do not worry about the units to say you're going to write this as 3 centimeters squared plus 4 centimeters squared. No, don't forget about those. You just need the units at the end. You're calculating the length, so it will remain with the same units as you are given. So this is where you are. You need to calculate. Remember the question, you need to calculate AC, but this is AC squared. All right, let's first simplify this. AC squared is equal to what? 3 squared. 3 squared, remember, you're back 3 times 3, which is 9, plus 4 squared, which is 16. You can even use your calculator there. Add these values together. So AC squared is equal to what? 9 plus 16, that was going to give us a 25. Okay? So at this stage, where you need AC, not AC squared, the question, we need the length, this one. So how do we remove these two, the exponent that is there? Remember the opposite whenever. Remember when you're solving equations like x squared is equal to 4, we had such equations like this. When you're solving this, how are you removing the exponent of 2? You were introducing the square root. So it's the same thing. There's a square there. Introduce the square root. Introduce the square root. So AC, its length is going to be what? The square root of 25. We can evaluate this. We know the square root of 25 is what? 5. Remember, 5 times 5 is what? Is 25. So the square root of 25 is what? Is 5. The length in what? Centimeters. So meaning to say our AC was going to be 5 centimeters as we had this length before. So we have to be careful. We have to be very, very careful, guys. All right? In our calculations. Let's have another question. As we can see, number 2, the presentation of our triangle is still the same. We need to calculate AC as the one that is facing 90 degrees, which is our hypotenuse. So we saw that AC squared is equal to what? AB plus BC, as we are going to have this. So it's AB squared plus BC squared. So we need to calculate AC, remember? So we have to substitute AB, which is 8. So that is 8 squared plus BC. We have to substitute the length of BC, which is BC, that is 15. So we're going to have 15 squared. So we are going to simplify this. AC squared is equal to what? That is from your calculator. 8 squared, which is simply 8 times 8. That was going to give you a 64 plus 15 squared, which is 15 times 15. That was going to give you 225. Then we add these two together. So we are supposed to add, that's AC squared is equal to 289 if you add these two. So how do you remove the square root? That is the same thing like our previous case, as we had this to say whenever you are given the square, this one, you have to remove it. So you introduce the square root like this. So the moment you have the square root, you are taking or getting rid of that 2. So you have the value of AC, which is the square root of 289. That was going to give us a 17. We can even use our calculator. Or you just have to know, guys, our perfect squares. Remember, 17 times 17 is 289. So the square root of 289 is what? Is 17. So meaning to say that was going to be the length of AC in what? In centimeters, as we have our units. So considering question number 3 is just a repetition, as we have this now as P QR. So we can consider this is Q, the length that we need to calculate. So you can just write this as Q squared, which is our hypotenuse. Remember, the one that is facing 90 degrees, that is our hypotenuse. So meaning to say Q squared is equal to what? The square of these two shorter sides that are remaining. Meaning to say we have got what? 12 squared plus 5 squared. We have our values already. So we're simply going to substitute that. So that is Q squared is equal to what? 12 squared. 12 times 12, that is 144 plus 5 squared, which is 25. 5 times 5. So that was going to give us Q squared. We add the 2, which was going to give us 169. So to determine the value of Q, so you have to introduce the square root. Remember, we need to get rid of that 2. So the square root both sides, that was going to give us the value of Q, which is 18 in what? In centimeters, as we have the other units that we have. So this is how we are going to evaluate, calculating using the theorem of your Pythagoras. On question number 4, a similar question again. If you are to consider the side facing the 90 degrees, that is the side F. So in that case, that is our hypotenuse. So what is the formula about from this? Hypotenuse squared, this hypotenuse that we are given, F squared is equal to what? The square of the shorter side that we are given, which is the 4 and the 10. So we're going to have 4 squared plus 10 squared, which are the right sides. So at the end, what we're going to have, f squared is equal to 4 squared, that's 16. 10 squared, 10 times 10, that is 100. We add these two, we are going to obtain 116. So as we can see, determining the square root of 116, it was not going to be an exact value. We do not have an exact answer. We cannot determine this as we have other values. Like let's say we are considering other values in our simplification, like what we have on 100. You can simplify that. But in this case, 116, we cannot. Okay, let's just have our calculator so that you see what I'm trying to say. The square root of 116, that is 2 square root of 29. We cannot simplify this. It is giving us a decimal. It's not an exact value, like maybe you are given, let's say the square root of 25, like we saw before, is just a 5, which is a whole number like that. We are not having that. We are not having that. So that is the condition where you are being told to say, where it is applicable, it is possible like this, you leave your answer in said form under the square root as it is. We cannot simplify this. So meaning to say f is going to be the square root of 116 in centimeters, or we can have simplified as we saw the square root of 116, that it gave us 2 square root of 29 from our calculator. So we can also have it that way. So we cannot have it like an exact value. So you have to follow the instruction. Maybe you're given to 2 decimal places, meaning to say you can use your calculator, have it as a decimal, then you round off. But in this case, they said for any length that is, we cannot simplify. We are supposed to use what? The said form. We are supposed to answer or give our answer in what? In said form. All right, so that was it on question number 4. Considering question 5, we are given, this is a right-angled triangle with the hypotenuse C and the sides of the following length, A and B. It's a right-angled triangle that we are given. It has the side, which is the hypotenuse. The hypotenuse, the one that faces the 90 degrees, the hypotenuse, which is called C. And we are given A and B being 9 and 40 centimeters. So let's say we are given this as our A, which is 9 centimeters, our B, which is 40 centimeters. Remember, the question is to find what? The hypotenuse. The question is still on determining the length of the hypotenuse. We are still on the same question to calculate the length of the hypotenuse. So from this, C hypotenuse, C squared is equal to what? The square of this shorter, the sum of this square, which is A squared plus B squared. So we need to calculate the hypotenuse. Remember the instruction that we had before, guys, on our question here is to calculating the length of what? The hypotenuse. So on that number 5, without being told, you're supposed to know that you're calculating what? The length of the hypotenuse. So C, being our hypotenuse, can be calculated. We have to substitute our values. So C squared is equal to what? A squared, which is 9. So that is 9 squared plus B squared, which is 40 squared. So you are simply going to simplify this. You're going to need your calculator. 9 squared, that is 81, plus 40 squared, that is 40 times 40. That was going to give us 1,600. So we have got 1,600. Then we have to add to 81. So plus 81. So C squared was going to be, it was going to be 1,681. Then let's remove the square by introducing what? The square root both sides. That was going to give us the value of C. So determining the square root of 161, that was going to give us 41. We can have that one as an exact value. So it was going to give us what? 41, which is in centimeters as we had other units before. So this is how we can simply evaluate or simplify for the given hypotenuse. But in this case, it is not about calculating of the hypotenuse. It is calculating the length of any side in a right-angled triangle. Any side, it can be the hypotenuse. It can be those shorter sides that we had before. Calculate the missing sides in the following triangles. Do not use a calculator and leave the answers in the simplest set form where necessary. Number one, this is a right-angled triangle, as we can see here. So the question is, we understand our Pythagoras theorem. It is used on a right-angled triangle to calculate the third side, as you'll be given two sides. You want to calculate the third one. So our formula, it is, guys, if we are given the hypotenuse, I'm just going to write in short. The hypotenuse side square, the square of it, of the hypotenuse side, is equal to what? The sum of the right side squared, meaning to say we are going to have the right side squared like this plus another right side squared. This is what you're going to have. From what we had from that triangle, when we said c squared is equal to a squared plus, if you understand it that way, use it like that. C is the hypotenuse, A and B are the shorter sides. So according to this triangle, what are we having? On number one, C squared, hypotenuse. What is the hypotenuse? We are given that is 10. So 10 squared is equal to what? The sum of the square of the shorter sides, the 6 and the A. These are our shorter side, the right side, the one that are adjacent to the right angle. So that is where we have A squared plus this other side, which is 6 squared. So that is how you solve this. So in using these values, in substituting these values into your known formula of the Pythagoras theorem, you can see that you have formed an equation where you need to solve for A. So how can you solve for A? All right, let's simplify this so that we can see these values properly. 10 squared, 10 times 10, that is 100, is equal to A squared plus 6 squared, which is 36. So we are going to solve for A squared. What can we do? Take the 36 over the equal sign. The moment it jumps the equal sign, it changes there. So it is going to be 100 minus 36. So that was going to give us what? 64, which is equal to A squared. We have taken this, that other side. It became a negative. You subtract. So if 64 is equal to A squared, remember, how were you removing the square? You were introducing the square root, or you were writing this 64 as 8 squared is equal to A squared. So meaning to say A is equal to 8. Or you can introduce what? The square root, as we had this before, the square, to remove this square. So meaning to say we are going to remain with the A. What is the square root of 64? The number that multiplies itself to give us a 64. 8 times 8. Remember that. So meaning to say 8 is equal to A, therefore A is equal to what? 8. So that is in what? Centimeters. The other units there are given in centimeters. Just like that. So you can solve for any side that you want. It's not only calculating of the hypotenuse, no. It is not only about the hypotenuse. It can be the other side, those two other sides, the right sides or the shorter sides. On number two, you've got the same condition. As we can see, this on 90 degrees. So the side facing 90 degrees is our hypotenuse. We have hypotenuse, which is 15. So 15 squared is equal to what? The sum of the square of the two shorter sides. What are we having on the shorter sides? The y and the what? The 12. So that's y squared plus 12 squared. So we can calculate the value of the unknown, which is y there from y squared. All right, so we need to simplify 15 squared. That is 15 times 15, which is 225. So 225 is equal to y squared plus 144 from 12 squared. So taking the 144 this other side, it was going to be a negative 225 minus 144 is equal to y squared. So that's y squared is equal to the difference, which is 81. So as we saw this previously, guys, the squared to be removed can introduce the square root both sides, or you can just ask yourself, how can I write 81 as a number to the power of 2? 81 is same as what? 9 squared, which is equal to y squared. So y is equal to what? 9. Or you can simplify this. What is the square root of 81? The number that multiplies itself to give us 81. That's a 9. So y is equal to 9 centimeters. So in this case, y is equal to 9 centimeters, as we had the other units from there. So these are the typical questions. As we can see, guys, not wasting much of our time. We just need to try as many questions as we can. On number 3, we have our hypotenuse, the side facing 90 degrees, which is 13. So 13 squared is equal to what? The shorter side, the sum. 5 squared plus p squared. So 13 squared, that's 169, is equal to 25 plus p squared. So take the 25 to the other side. It was going to be what? A negative 169 minus 25. It was a positive, remember? So it will be a negative. So all this, p squared is equal to what? The difference there, which was going to be 144. To remove this square, you introduce the square root, which is 12. Just like that. So meaning to say our P is going to be 12 centimeters. So questions can be given in any format. On this other question, what are we given? This time is the hypotenuse straight that we need, the hypotenuse. P facing 90 degrees is our hypotenuse. So remember that the hypotenuse is squared. P squared is equal to what? The sum, the square of the shorter side, the square of this shorter side, 7 squared plus what? 24 squared. So meaning to say we can simplify. P squared is equal to what? 7 squared. That is 49 plus 14 squared. You have to multiply 24 times 24. That was going to give us 576. So adding these two together, as you can see, already P is on its own. So we are not going to take this P to other side of the equation. We are going to add what we see on the right side. So this was going to give us 625. So removing this squared, introducing the square root. So that's having the value of P, which was going to be 25 as we are given. So this is 7, this is 24. So this is 25. We do not know those are meters, those are centimeters, or what. We just write the way that we are given them. Right-angled or not, determine from this whether these triangles are right-angled or not. If truly it is a right-angled triangle, we saw that if truly it is a right-angled triangle, if this is C, if this is A, if this is B, we saw that the hypotenuse, which is C squared, must be equal to A squared plus B squared. Where this is the longest side, the hypotenuse, that is the longest side, must be equal to the square of what? The shorter ones, the shorter sides. So you have to test by this. If it is not equal to this, therefore it is not a right angled. So you must test using what? The longest side of all the given sides on your triangle. What is the longest side? Test with that longest side. If it is truly equal, therefore it is what? A right angle triangle. This can only happen only on a right angle triangle. Only on a right angle triangle. Only on a right angled triangle. That is where we are having this. On a right angled triangle. If it is not a right angle triangle, guys, we cannot use this. All right, here I just shifted some of these. Or say it only on a right angled. On a right angle triangle. That is where we are applying this Pythagoras theorem. So we must be directed from where? From the longest side of what is given there. Let's consider the first question. The longest side is 10, comparing these two, the 6 and the 8. The longest side is 10. So we are going to take that and square 10 squared. Is it equal to this? The shorter sides square, the sum, which is the 6 and the 8. So 6 squared plus 8 squared. Let's see. This is going to give us 100 is equal to 6 squared. That is 36 plus 8 squared, which is 64. So 100 is equal to, we add this, we're going to obtain 100. So as we can see, truly these two, they are equal. So therefore, it is a right angled triangle. It is a right angled triangle. A right angled triangle. It is only because of this, if this is truly equal. If it is not equal, it is not. You work with the longest side, the biggest one, the hypotenuse, the one that you think is your hypotenuse. So on number 2, the longest side is what? Comparing this side, the longest side is 13. So if we are to say the longest side is squared is equal to the square of the shorter side, these are the shorter sides, 5 squared plus 12 squared. We have to test. So this was going to give us 169. You find this 5 squared, that was going to be 25 plus 12 squared, which is 144. So that was going to give us 169, 169. So as you can see, they're equal. So meaning to say, therefore, this is what? A right angled triangle. It is truly a right angled triangle. So that is, we are comparing to see, is it a right angled triangle or not? On number 3, we want to know, is it a right angled triangle or not? If it has sides measuring 6, 9, 15 units, a triangle is just drawn. We do not even know the type, but it is having side, another 6, another one is 9, another one is 15. We want to know, is it a right angle triangle? That triangle is it. So like I said, we work with what? The longest side. According to this triangle, the longest side is what? Is 15. So you test from there. 15 squared is equal to what? We square the shorter sides that are remaining. That is 9 squared plus 6 squared. So 15 squared was going to give us 225 is equal to, we simplify 9 squared, which is 81 plus 6 squared, which is 36. Then we can add these two. This part was going to be 225. Then we add 81 plus 36. That was going to give us 117. So as we can see, these two are not equal. This is not equal. C squared is equal to A squared plus B. It must be equal. But in this case, it is not what we are supposed to be having. It is not equal. So it means this triangle is not a right angle. It is not. It is not a right angle triangle. So it can only be a right angle triangle if the left-hand side is equal to the right-hand side. So this is what you're going to do on this information. You can work out as many questions as you can. Just try to check out these triangles, right-angled or not. So you just have to test, like let's say we are given on F, in that case, which of the triangle length will form a right angle? Where is it going to form a right angle triangle? Answer without doing any calculations. All right, so some of these, remember your Pythagorean triples, where you can even check and see 6, 8, 8. These are Pythagorean triples. We are going to have a right angled triangle there. 3, 4, 5. We are going to have a right angled triangle again there. So you can test these 30, 40, 50. If you have 3, 4, 5, it means 30, 40, 50. These are multiples of 3. They can simply have the same thing. But here we cannot. Here we cannot. So you have to test. 9, 12, and 15. Are you going to have that if you square 9 and 12 squared? This is part of a right angled triangle again. So I want you to test that with understanding of your triangles, right angle triangle, the information that we discussed together. As you are to revise your activities, just try to go through that part. So let's revise. We are going to meet again with question papers and see how are they going to ask these typical questions as we are preparing for our exams.